Now let's look at the exercise 4. So this is exercise 4. So you have to determine or find the voltage V1 and also the V2 across the 2 ohm and also 4 ohm resistors shown in the figure below. And the loop is located in the XY plane. Okay, XY plane, this is the X, this is the Y, XY plane. Okay, and its area is 4 meters square. So in this question, they didn't mention about the length of the side, but they just mentioned the area is 4 meters square. And the magnetic flux density, okay, is equivalent to this one, and in the Z direction. Okay, and the internal resistance of the wire may be in naught. Okay, so forget about the resistance in the wire. Okay, just concentrate these two resistance. Okay, so you have to find these two voltage. Okay, so let's draw this loop, okay, separately here. So this one is the reference X and Y, and I define the Z direction will be the direction coming, positive Z direction will be the direction coming out from the page. Okay, and if you look at the information from the questions, the B is in the negative Z direction. That's why I draw this one to represent the direction of the magnetic flux density, and the area is 4 meters square. Okay, so before we start, we have to determine, okay, the types of EMF. Okay, again, we found that there is the T here, so it means that the magnetic flux density change according to time. So it is transformer EMF. Okay, so we will use back this equation. Okay, transformer EMF. And for the N, since there is only one loop, so we put 1 here, and the B is given. Okay, B given. Again, the DS, we have to define the DS. Since we are using the Cartesian, so we will use the Cartesian coordinate to represent the dx. So here will be dx dy, and the direction will be z, positive z. So we can cancel these two vector, unit vector, and it produces 1. Okay, so next we will perform the partial differentiation with respect to t. So we will get 0.3 here, and this negative I combine with this one, we get positive. Okay, so now we need to define the interval for the x and also the y, okay, for this loop. Okay, x is here and y is here. Actually, we don't know what is the length of the sides of this square loop, okay, but we know that the area is 4 meters square. So you have a choice. Either you want to assume it to be from 0 to 2 for x and 0 to 2 for y. Okay, when you've done this one, okay, you will find that the area is 4. And you can also choose, okay, either one x or y. Okay, the x will be 1 and the y will be 4. You can also get an area which is equivalent to 4. Okay, no matter which one you choose, at the end you must have an area which is equals to 4 meters square. Okay, so you continue the integration using calculator. You can get the generated EMF is 1.2 volt. Okay, 1.2 volt. So in order to know the current flowing in the loop, so to know the current flowing in the loop, we have to use this equation. V divided by R. Okay, so you will get your current in the loop, which is equivalent to 0.2 ampere. And when you want to find the voltage across these two resistance, you just multiply the I with their resistance. Okay, so you multiply the I with 4 and also with 2. Okay, then you can get the voltage. Okay, V1 and also the V2. Okay, so this one will be the answer for exercise 5.